Welcome to our first premiere video here of Pickleball Paddles 101, a little education session with one of the best engineers in the world at all sports equipment, but in particular, understanding the ins and outs of pickleball paddles better than anybody. Curtis is from Pickle Pro Labs down in Boca, Florida, even though he resides in Louisiana. I, of course, am the president. I'm Jason Aspis, president of UPAA, and we're overseeing the paddle regulations for the UPA, particularly at the professional ranks for PPA and MLP. And this has been a long journey. We've been together on this for the last 8 months or so, but learned so much about paddles. And I wanted to, kind of clear the air. We hear a lot of misconceptions and misinformation out there about paddles and about what's going on. And I wanted to be able to kind of level set and shed some light onto what we're doing, why we're doing it, and how we're doing it. And I thought no one better than you to talk about it. So first of all, Curtis, welcome. I want you to introduce yourself and explain to the viewers who you are and what your level of expertise is in not just pickleball, but in all sports.
Yep, I appreciate that, Jason. It has been a long time coming, but I appreciate the opportunity to talk about all the work we've done and to clear the air and to explain to people as openly as we can what's going on, what we're doing, because the aim is to be as transparent as possible. And it's hard to do that across all platforms all the way. So we want to be here to answer all the questions we can all the time. So my background, I'm from Washington State University. I've got a master's in mechanical engineering, and more specifically, my master's work was in sports science. Was one of the original co-founders and inaugural students in the sports science laboratory at Washington State University, chaired by Dr. Lloyd Smith. And Dr. Smith was one of the godfathers of, if you will, of baseball and softball bat testing, working with Dr. James Sherwood, Dr. Alan Nathan. Those guys really set the foundation for what it meant to incorporate science into sport and find a way to quantify and then set standards and certification requirements for performance products. So while at the university as a part of the master's program, we built on behalf of USA Softball, ASA Softball, the first cannon that was designed to measure the performance of softball bats. That was really foundational. Went into the creation of the ASTM standard 2219, which is kind of the foundation of what we're doing in pickleball. Also now went on to kind of be, again, the foundation in lots of other impact sports where you've got a bat and a ball or a striking implement in a ball. So we've been doing this for a long time, not just in baseball, softball, but also been involved in testing and everything from football products to medical products. So yeah, been a long road, but happy to be reliving it again. Sometimes it's what it feels like because we've been through this before, but excited to kind of adapt what we've done in the past, take those learnings and create something new and better with pickleball.
Yeah, and I just want to touch on a couple of the names that you mentioned because, obviously when we first started this journey, we talked to Dr. Smith at Washington State. We ended up going Dr. Sherwood, who had gone to UMass Lowell and set up the baseball research lab there along with Patrick Drain. We went in that direction for our kind of academic side of things. But also you mentioned the softball regulatory, I guess it was the ASA, was the American Softball Association. Is that right?
Amateur Softball Association.
Amateur Softball Association. But that's Ron Radaganda, who is now on the PPL side of things, Pickle Pro Labs, as the kind of director of communications, helping us. He's helped me a ton in navigating how to govern properly and take this really seriously. It's, it is serious business, and you're obviously affecting manufacturers in regulating how they behave and manufacture.
Yeah, when we were going through that process, and I say we loosely, right? Because as a college student, we weren't necessarily leading the efforts and the communications with the governing bodies and the manufacturing industry, if you will. but Ron was really the adult in the room, if you will, right? He was the CEO, the president of the organization, and it was his vision that brought new standards into softball, because what had happened, the technology got far out in front of the certification requirements that existed at the time, and it happened fast, right? As you can start to see in pickleball, right? Like you wake up in one day and all of a sudden there's 3 paddles that are way better than anything you've ever seen before. It was the same thing in baseball and softball. Suddenly you were hitting balls 20, 30, 40 feet farther than ever before. And these bats still met the standards that existed at the time. And so, it was Lloyd, Dr. Smith, that led that effort to say what's going on here, and did a real analysis of the various ways you can measure performance. And there's different applications where different metrics make more or less sense. And sometimes it's an opinion, whatever, science tells us the facts, and we can apply them in lots of different ways, tuned around the specific requirements of a governing body or whatever your objective may be. Right. So it was back to the point, Ron, who really led that effort. And so he's been instrumental in helping us again say, hey, remember when this happened, don't say this, avoid these types of things. It's better to be inclusive and work with the people as we go. So anyway.
Well, and it's interesting that you say that, because, I hear that all the time. Be careful what you say. You can't say that, Jason. And we're living in a different time than back when softball bats were coming under the gun or baseball bats were changing. It's the world of social media. Everyone wants an answer immediately. We live out loud. We all have these channels to the world, and there's a lot of love out there for their paddles and these brands, and there's a lot of kind of angst out there. So we want to try to get that information as quickly to the public and to these manufacturers and to the aficionados, the pickleball players that want to know what's going on, as quickly as possible, but also as accurately as possible. So I'm trying to do that the best I can. I know I spend a ton of time on Twitter and Facebook answering questions and, trying to get the correct information out there as soon as possible. So
yeah, things certainly move faster now, right? The process we have to follow, unfortunately, doesn't move as fast as the internet and podcasts in general now, right? So it's hard to keep the information out in real time, but we just try to keep our heads down and stay on course, right? Because the more reactionary we become, the less genuine things are, right? We've had the path that we're on, we've been on for well over 18 months, right? Go back and look at the dates on the original white papers at the PPL. Yep. I mean, the idea is the path forward has been there for a long time. Largely it's been the same group working on it. And now we're just happy to kind of have this out in the market and want to do everything we can to help support the sport and the game.
Yeah. And I would point everybody to go check out pickleprolabs.com, because the white papers, there are 2 white papers up there currently. One is from back in the summer, I think, of 23, where you were first, acknowledging that PBCOR was something that we needed to look into. It took obviously some time to get there, but we are now here. And even though we don't call PBCOR for UPA, we call it PEF, paddle efficiency factor. And so that is to try to alleviate any confusion in the marketplace, because obviously USAP has taken on their own PBCOR version of that. But ours is different. And, you were one of the authors of the ASTM. Do you want to talk a little bit about the differences of what we're doing versus what USAP is doing, and why we see differences in the numbers and the output?
Yeah. So, I can speak only to what I know to be fact, right? We certainly hear lots about the USAP standard that's out there, but I've not seen procedures myself, right? I've not been through that lab to watch their latest protocols. So rather than speculate, right, I can just highlight what our process was. And so what our process was to look at the various ASTM standards that were relevant, 1890, 2219, and adapt them to what we think and thought would work for pickleball, right? So you look at those standards, say, all right, well, obviously this is different and that's different. So we make some very basic modifications to make sure that the test can physically run under our requirements with the paddle and a pickleball. From there, the details are really where you need to dive into, right? Because you have things such as, well, let me take a step back, actually. So when you do that, the whole reason for the process and for these certification standards in the lab with the cannon and measuring the ball and ball in and ball out and all those measurements is we need to find a way to eliminate as many outside variables as possible, right? We want to isolate the paddle as much as we can to measure the true performance of it. We're not looking to say necessarily in any given scenario, this paddle will never hit a ball harder or faster than some objective number. What we're trying to say is under certain conditions, these paddles will perform in this way. And it gives you a very nice ranking. And if you do it properly, those rankings and ratings will align with what you see in the real world, right? So a big part of what we do is always making sure that here's what we have just measured and does it line up with what people think is real? And not to say that what people think is real is always a fact, right? There's always going to be differences where perception is hard to overcome. But by and large, we're very comfortable in the data we've collected and how it aligns with expectations. And so when we start to then further refine the tests for our needs to make sure that those results line up with the real world outcomes, we need to look at all of the other variables that are still existing, right? So we're looking at the ball specifically. Does it have holes? Does it not have holes? What happens if you impact those balls with holes and without holes at 30, 40, 50, 60, 70 miles an hour? How long do they last? Is there a larger variance? Is there just a total breakdown, right? What are the ways that things fail and how does that affect the outcome of our test? And so when we went through the process, we learned many things. Some of the, I think probably the most foundational and what we're doing is the way we control the ball, because when you analyze the ball in as much detail as we did, right, we looked at countless balls over the course of 2-3 months, running multiple studies, first to see what's the difference between a ball with holes and without holes. What's the difference between a ball impacted on this face or that face? What's the difference between a ball impacted at this speed versus that speed versus that speed? How do those speeds correlate to what happens on the court, right? On a serve or a dink, or we look through all the variables, right? And no single solution is necessarily perfect, but we feel like we've landed on parameters that both are representative of what happens in the game, and then also outcomes that are also representative of what happens in the game. So, right, it's probably another podcast to really get into the details and the nitty gritty, and I'd probably pull in Patrick Drain to speak over my head at the. You can watch him derive on the whiteboard these equations as we're going through them. But I think, yeah, what I mentioned about the way we've studied each of the steps and what goes into it, that's really the foundation of what we're doing and why our data has been holding up well so far.
Got it. Okay. Yeah. I mean, I think I can only speak to what I've seen because I think I'm the everyman. I'm the layman asking you the questions that you kind of roll your eyes at, but it's the same questions that I hear every day on the court and in the chats. We want to understand it. We think that we have some logic in our head of why things are the way they are, but you can apply the science to it and give me a pretty concise answer. So I appreciate, you setting me straight. And, one of those things that we were talking about of what the perception is versus what the reality is, sound often plays a huge part of this, right? I hear it all the time. When things sound different, when a new paddle comes out, sounds different, everyone freaks out. Everyone thinks that something's going on. They think they can identify it. And sound is so tricky, right? It really does play with our perception of speed and, anticipation. And so that's one of those that when things sound different, people freak. And it doesn't always equate to what's happening in the lab or in reality even.
Yeah, it's right. It can mean lots of things, or it can mean nothing. Right. All else being equal, if the sound of a particular paddle is changing over time, that's likely indicative of a physical change to the paddle. But it doesn't necessarily mean that paddle has changed in a way that the performance has changed. It just means the sound has changed, right? So in Other sports, the sound is more closely tied to the frequency and the sound that, like a baseball bat, for example, right? The way the barrel flexes in and rebounds, the frequency of that vibration is actually the sound you hear. That's the ping you hear, that the ping of an aluminum ball or aluminum bat and ball. That's not the same sound you hear in pickleball. And it's a different sound. It's driven by different things, right? We'd have to get Dan Russell on here from Penn State to really dive into that acoustic world. But it is, yeah, to your point, it's hard. It's a hard topic to talk about because sometimes it means something and sometimes it's a red herring, right?
Yeah, I know. I'm the one who pushes on sound all the time, and I think sound actually is I know how complicated it is, and that's a conversation for a later day. But we're on it. We're thinking about it. But the purpose of this was a bit of a Q&A to let people, in the audience that do care about this kind of stuff be able to interact with us and get the answers directly from you. So I put this out on my Twitters at Spus44, SPUS44, and also on Facebook. You can find me anywhere on Facebook, particularly in the kitchen. I'm always hanging out there answering questions. But I did get a bunch of questions, and I'll ask a few of them here. This one's from Richard Moss, who he brought up a point about how many failures deems a problem where action needs to be taken. And I think that leads us to, what we've talked about, what we've seen in other sports is, the playable life of a paddle. And I know that we borrowed that from other sports equipment regulatory bodies. You want to talk a little bit about that and what we're setting out to achieve here? And once again, remember, we're talking about UPA Pro Game. That's what we're certifying for. But yeah, Go ahead.
Yep. No, that's an important thing to continue to clarify, because you get, if your head goes a different direction, it starts to sound like you're trying to control the market. So, it's a good question, right? It's because you don't want one single outlier failure or paddle that exceeds the limit to eliminate an entire batch of production, right? You're going to have some sort of manufacturing variance, right? Unless you're sorting and qualifying and only releasing some tiny percentage, you're going to have to live with some sort of variance in manufacturing. Most of it should be very reasonable and should be well within the standards that we're setting. That said, you don't want to take an outlier necessarily and ruin an entire product line. And so overall, right, is one of the things that we talk about with you, Jason, right, is understanding, like, maybe there's a red flag that triggers additional testing, right? So typically what we would say, if we see something that is noteworthy, we then go and we can sample the market and we can evaluate the performance, and it really triggers that compliance process that we've started to outline and you started to post on the web a little bit. So that overall, that's how the process would work. But yeah, when it comes to the useful life of a paddle and like, how do you define what's a failure and what's not? That to me is something that is like super critical, right? Because when you look at what is a failed paddle, you can define it in multiple ways. You can say any paddle that ever exceeds the limit in a test fails, no matter what. That becomes so drastic that it feels, as a product development person, like unfair and impossible to do, right? Because if I've created a paddle that for many months and many tens of thousands of impacts stays right where it should, and then it physically starts to break and it degrades to the point where I would say it's broken and should be returned, or you buy a new paddle, you could say that's a failure and you've exceeded the limit, right? And so it's in that vein that when we use words to define failure and the life cycle of a paddle, we're extremely intentional about the words that are used, right? And again, I know you've got it posted on your website. People can read it, but we talk about the useful life of the paddle, meaning that once a paddle shows a physical failure, an audible change, right? Back to the noise a little bit, right? And here we're talking more about rattles and shaking and loose parts. But when a paddle, right, if you can squeeze it together with your fingers and you see true deflection and the two faces are touching, when a paddle has clearly changed beyond its OEM state or as it was manufactured, then it feels like as long as that is observable to a commonly trained individual, that should kind of be the end of the life of the paddle, right? That's the way that many other sports have looked to address issues like the lifetime of the paddle and break-in and things like that. So that, I believe, is kind of critical to how we look at the standardization and the qualification of paddles and how they perform through time. I think it's just important to understand what it means for a paddle to have seen its useful life, if you will.
Yeah, we talked about this the other day. We called it CCR, cracking, crunching, and rattling. So not the rule yet, but that seems to be a pretty good, direction for where we're heading. So we will articulate that.
Really, right. It's the only practical way to put a finish line in front of a manufacturer who's trying to develop a product line and a product for a standard, right? You could say it just infinitely, it can never change. Man, that's just really hard to do. Feels a little bit disingenuous, and you're just setting people up for failure, right? We want to have repeatable and reliable standards, but they shouldn't be set in such an unattainable way. So we want to do our best to, we're not going to make everybody happy, but I think we can set standards that are at least fair and reasonable.
Yeah, and I want to make sure the education's there as well. People need to understand when their paddle starts crunching or cracking visibly or rattling around, that it's time to put it down and look into another one. And these things change over time. We know they do, and at some point they're not supposed to be played with. Okay, another question from Ben Lewis, who had a question about weight, and he was asking, when adding weight to paddles in varying amounts and locations, does this have a material effect on the results of the paddle testing?
Let me try to think of a really simple way to answer the question. When you test a paddle, whether it's an OEM paddle or it's an OEM paddle that has had weight added to it or taken away, whatever it is, the PBCOR value that you get after testing that paddle will be like a fingerprint for that particular paddle. As you start to add weight or take weight away, as it turns out, right, in the threshold of weights that like are playable weights, right, we're talking like 8 to 10 ounces, whatever, something in that range, that the weight difference turns out to be pretty small and to have a very small impact on the overall PBCOR value. That's not to say it doesn't have an impact, and we can get into. I think right, there's, especially if you look at the derivations of some of the actual metrics inside of PBCOR and PEF, right? You can start to say, well, now inertia is involved, and we're not even talking about the weight now, right? The conversation gets pretty deep down, but the short answer is that weight changes within the range of playability don't tend to have significant effects on the PBCOR values of the paddle. And I think the conversation gets a little bit more nuanced and detailed. We don't want it to sound like we're avoiding that part of it, so we can certainly dive deeper, but I think for the sake of that particular question, that's probably a fair answer.
So another similar question, this is from Keith Knauss, and he's asking about PBCOR, and this is a super nerdy, very, technical question, which is, I'm going to read it to you. I'll cut this out because I'll post it on the thing.
You would describe it as a nerdy question. I would say I appreciate it because, frankly, this question can be answered directly as opposed to the previous question, which sounds much simpler, but there isn't like a direct answer for, right? So yes, the question or the point that's being made, I think, is that in the calculation of PBCOR is in a small way a function of, which means is in a small way dependent upon the inertia of the paddle. The inertia is, right, simply speaking, the swing weight of the paddle. So high inertia would mean like it's hard to swing, it's end heavy, tip heavy. And a low inertia means it's paddle or handle heavy, if you will, easier to swing. So a couple points to address on that. So first, the way the performance of the overall performance of the paddle as measured by PBCOR is a like organic and dynamic test, right? It spits out, you're physically measuring the ball go in and the rebound back out. You also measure the paddle spinning away as well. But in those measurements, it accounts for, because that paddle has an inertia, the ball has an inertia, right? All of those things are physically accounted for. They exist and they're a part of the measurement system. So you can't simply look at the equation and like reverse engineer it and say, okay, in this condition, with this paddle, with this inertia, has this PBCOR value. It's not appropriate to just take then and use or treat the inertia variable as a true variable and slide it up and down to see the range of what might happen or might not. The reason it doesn't work is because as you actually would physically change those inertia values, your PBCOR value would also change, because like we said before, the PBCOR measurement is dependent upon that inertia value. So that's one flaw in that general the general idea or comment that was brought up. The other way to look at it, though, is that inertia in the range of playability, all of the things I've said stay true. When you start getting into a paddle that weighs 8 pounds, right, artificially, you put an 8-pound weight at the end, or 8 pounds on the handle. Look, like that is a different thing, and it's not what we're talking about here. So there are extremes, certainly, where you could run into issues and you would be measuring things in the lab that aren't necessarily consistent with what's seen in the court. So fortunately, we don't seem to have that problem because we've got a fairly tight bound on paddle weights that are used in play. But one of the things that, right, we keep an eye on is that if it were to be an issue, right, if we decide, hey, you know what, this variance that's this much, it's too much and we want it to be that much, we can do things as other sports have, right? The BESR test, which is the standard that was in place and helped develop by Dr. Sherwood at UMass Lowell and Patrick Drain, who we mentioned before. That standard actually was basically qualified by MOI ranges of the bat, right? So for a bat of this range, your BESR was allowed to be this. For bats of this MOI range, it was this. So you can do things with the way you build the standard to further control for like some of these nuances we're talking about. Again, like as we're coming out of the gate and we're starting to see how the PBCOR values tie to what's happening on the field and in the court, it doesn't appear that that's going to be necessary yet. But also these manufacturers are just now learning this as they go, right? It may be that we need to further refine and qualify and put other bounds on the way that we do testing. But so far, based on what we've seen, it is not an issue. The third point, I said there'd be two, but the third was regarding like the ability to swing a paddle faster or slower. Right. The intuition is that a low MOI paddle should be able to be swung faster, and a high MOI paddle would be able to be swung slower. In the theory being that the paddle that you can swing the fastest the heaviest paddle, the highest MOI paddle that you can swing the fastest is the best for you in that it allows you to hit the ball the hardest, right? It allows you to optimize power. Lots of studies have been done on that in the baseball, softball world. I've not seen those similar studies in pickleball. It is absolutely a different swing, right? That's where it kind of falls apart. You can't just assume that the swing speed formulas and MOI dependencies that you see in baseball and softball are going to be the same, or maybe they don't exist at all, right? Maybe the weights and the MOIs are so low that like moving your arm is harder than moving the paddle. So like your ability to just swing in general is more dependent on your biology and your kinetics. So yeah, we don't know the answer to that, but the studies are out there in other sports, and certainly there's a path forward to do that in pickleball as well as we continue to learn more and more.
Thank you. Clayton Cooley has a question about spin test, and he asks if PPL says they chose the 30-degree because it gives variance between results for different paddles. 45-degree gives no slip conditions, so all paddles test the same, and 15 degrees, all paddles test the same as well for different reasons. USAP, on the other hand, is testing at 45 degrees in their upcoming spin test. How do you reconcile the two tests when what USAP has selected is in direct opposition to PPL's thinking?
This is one of the instances, and again, I've not seen a procedure written. I've heard rumors and seen some podcast videos of them talking about it. But this is one of the more shocking ones because what I have heard absolutely flies in the face of and is directly contradictory to what we have both measured and the common understanding of spin rate and impact in sport. I don't know any other way to say that more politically correct than that. I mean, what we see is pretty clear in the testing. The closer you get to a 90-degree impact, right, in a 90-degree impact, the ball comes in as a knuckleball and it goes out as a knuckleball, right? There is no spin induced. As you start to turn that paddle, you get a ricochet off of it, and the rolling or the rotation off of the paddle face is a direct function of the sliding or how that ball slides on the surface in that surface interaction. And under what we would consider or call, and like it has a real definition, a non-slip condition, all paddles are the same. And 45 degrees is like, for certainly a competitive paddle, almost all those paddles at 45 degrees have a non-slip condition, which means what you have on the surface doesn't really have an effect on spin. The more you get parallel to the incoming path of the ball, the more the ball slides on the surface, in which case, right, you go flat or 1 degree, it's going to slide right past every paddle, and they're all going to test the same again, right? So at 90 degrees and 0 degrees, everything's the same. They have infinite spin and zero spin. And as you start to change that angle in between, some paddles are a straight line, some fall off like this, some go like this. And it's that difference in how they perform at different angles that we care about, right? Because that's the difference between a cut shot or overhand spin, right? That if all of the paddles were just, if everyone was holding their paddle like this and just plowing through the ball, they would all kind of have the same spin outcome. But they don't, and we know that. And the only way to physically measure that is to do what we're doing, at least in a similar way to that we're doing. Certainly, there's multiple ways to measure spin, and you can do it with multiple cameras and one camera, and there's lots of ways to look at that. And it's probably for a debate for another time to talk about the correctness of multiple camera systems based on the conditions we're looking at. But as far as why we're doing what we're doing, it's based on the physical differences in the paddle and what we see on the court and how paddles actually perform.
Can you dispel something for me? Many people still believe that the grittier something is, the more spin it creates. Fact, fiction?
I think back to what was the show where they Mythbusters, because they had a middle ground. They had plausible, which meant kind of like a maybe. So let me answer it like this. So generally speaking, in the range of surface roughnesses that exist in the market today, right? So call it 20 to 80, right? I think the threshold's 40, but a lot of variance in that metric. In that range across all the paddles, when you measure the spin rate of each of those paddles, you find no correlation between surface roughness and spin rate. So the only asterisk to that is that for a given paddle, if you increase the grit or decrease the grit for the same paddle, that probably will have some small effect. But that's really the only asterisk, right? Is like across all paddles, there is no general trend. And it's because if you had grit that was like so strong and sharp that it was cutting into the ball and you're like, it was like Velcro, right? Then you actually start to make a difference. That has an ability to change the angle at which the non-slip condition happens. But for the grit ranges we're looking at, it's almost imperceptibly different in that dynamic condition, and it doesn't really seem to have a significant difference on the spin rate. So I would say that is mostly true, that spin rate and surface roughness is not strongly correlated, but it also, again, there's a lot of details in there, and we try not to make like overly general statements like that, but yeah, to answer the question, I think the evidence is pretty clear.
Okay. This is one question from Twitter I'm going to take this one, by the way. This is, I think it was directed towards me, from RM Pop Pop. One of the stated goals of paddle regulation is to reward skill and creativity. I don't believe those terms are defined, nor is there an indication of how they are to be measured to determine success. Can you expand on the goals related to those aspects of regulation? And yeah, I mean, so when we say skill and creativity, we want this game to be dynamic. We want to reward all different shots. If we allow too much power into this game, and we're seeing it right now, power dominates everything else. You can't reset. The drop isn't nearly as effective. Dinking isn't as effective because you can light people up. You can accelerate the ball, speed up, and you are rewarded for it. Where if we, had power back where it was a couple of years ago, we didn't see that. Now we have to balance that and make sure that this game is exciting to watch and dynamic and fun, but we want to reward a full, arsenal of shots. So we want everything to be in play. And then strategy ends up becoming what wins with everyone being equal. But we don't want people to be able to just bang away and dominate, which is unfortunately what we're starting to see. And we're very kind of cognizant of that and want to protect the integrity of the game in that manner. What the magic of the sport is, and this is, take away the pro game for a second. I think the magic of this game is at the rec level, intergenerational play where a grandma can play with her grandkid, and you don't know who's going to win because it's not just athleticism, right? It's knowledge, it's strategy, it's execution. And so being able to keep that at the core of the game, I think, is incredibly important in what we all fell in love with this game to begin with. So that's my answer to that. Curtis, that's all I got for today. I appreciate your time. If there's anything else you want to say, anything that's on your chest?
No, I really, again, just happy to have a platform to answer questions that are helpful to the audience. And not just me, but, I know we've talked a little bit about making this a series, if you will, to dive into some of the finer nuances of the testing and talking about how do you hold the paddle, right? There's questions about that. There's questions about lots of different things. And we've got not just myself, right? Not just Patrick Drain, not just the older experts, but we have young engineers who have dedicated themselves to the science of sport and engineering that I think are appropriate to get on and talk about some of those things as well as we look into the future.
I love it. That's what we'll do. We'll make this hopefully a weekly segment, and we'll bring on different engineers that are working on the paddle testing to answer some questions that you have, and try to be as transparent as possible, and let you guys have a little sneak behind how it all works. So appreciate you watching. If you've gotten this far, you really do care, and we love that you do. So thanks, and we will see you next week.
Thanks, guys.